Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of differentiation. And if I talk about the question that is given to us here from this topic, the question tells us let the function f of x equals ax cube plus bx square plus cx plus 41. The question tells us three conditions, that is f of 1 is 40, f dash of 1 is 2, and f double dash of 1 is 4. The question is asking us to figure out the value of a square plus b square plus c square. So that's the question asked to us. And if I talk about the answer choices that we have been given here, the options are 54, 51, 30, 73, and 62. So we have these four answer choices given to us. Let's figure out how to solve this question further. Before starting off with the solution for this question, I'd first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you. So let's see how to solve this question further. So I have my function f of x given to me, ax cube plus bx square plus cx plus 41. Now if I find the first derivative of this function f of x, I get a derivative of x cube is 3x square plus b derivative of x square is 2x plus c derivative of x is 1 and the derivative of the constant is 0. So I get this. Now if I find double derivative of this function f of x, I get a. This basically becomes 3 and derivative of x square is 2x. B derivative of 2x is just 2. So we have these three functions. Now if I put the values of x equals 1 everywhere, my function at f equals 1 becomes a plus b plus c plus 41. If I talk about the first derivative of the function at x equals 1, it basically becomes a 3 into 1 square, so 3, plus b into 2 into 1, which is 2, plus c. Then if I put x equals 1 in the second derivative of this function, f double dash of 1 becomes a 3 times 2, which is 6, and x equals 1. So it becomes 6 and 2b. Now if I just put the values that we have been given here, it says f of 1 is 40, f dash of 1 is 2, and f double dash of 1 is 4. So f of 1, I put it as 40, I get an equation a plus b plus c plus 41 equals 40. That gives me a plus b plus c equals 40 minus 41, which is -1. So that's one equation that we have. Now if I put it f dash of 1 here, that is equals to 2. So if I put it here, I get 2 equals 3a plus 2b plus c. And if I put that, I have this as equation 2. And here if I put f double dash of 1, that is 4. So 6a plus 2b equals 4. That is equation 3. So we have three equations in terms of a, b, and c. If I solve this further, let's see how to do that. So we have three equations. First says a plus b plus c is -1. The second says 3a plus 2b plus c equals 2. And the third says 6a plus 2b equals 4. So now if I divide this entire equation with 2, I get from here 3a plus b equals to 2. And once I have 3a plus b equals to 2, I can write b as 2 minus 3a. Now once I use that b as 2 minus 3a, I can use that in the first two equations as it is. So if I put it in the first one, I get this as a plus b is 2 minus 3a, plus c equals -1. So if I solve this further, I get minus 2a plus c equals -1, and this becomes -2, so -3. And if I put that b as 2 minus 3a in the second equation as well, I get this turning out to become 3a plus 2 times 2 minus 3a plus c equals to 2. So I get 3a plus 4 minus 6a plus c equals to 2. So that gives me minus 3a plus c equals -2. Negative 2 because 4, if it goes on the other side, becomes minus 4. So 2 minus 4 becomes negative 2. Now I have two equations. Let's say this is equation 1 and 2. So if I solve these two equations simultaneously, now I have the first equation as minus 2a plus c equals negative 3, and the other one as minus 3a plus c equals negative 2. Once I have the two equations with me, if I just solve them, subtracting the two equations, I can change the signs here. And if I change the signs here, I get this and this cancelled. Minus 2a plus 3a, which is a, and minus 3 plus 2, which is negative 1. So we have a as negative 1. Once I have a as negative 1, I can just substitute in the other equation and get the value of c. So let's find that. So c becomes minus 3 plus 2a. That is minus 3 plus 2 into negative 1, which is minus 3 minus 2, which is minus 5. So I get c is negative 5. And once I have a and c with me, I can write my equation, which is a plus b plus c is negative 1. So negative 1 plus b plus negative 5 equals negative. So from here, I get b is 5 minus 1 plus 1, which is basically 4 plus 1, which is 5. So I get b also as 5. Now if I see I have all the answers for my variables, a is negative 1, b is 5, and c is negative 5. Now once I have this with me, if I just find the sum of their squares, I get a square plus b square plus c square. And that basically becomes negative 1 square plus 5 square plus negative 5 square. So that is 1 plus 25 plus 25, which is 51. So I get the answer to the question that is asked to us, the value of the expression, and that matches with 51. And if you see the answer choice that matches here from the question, it is option B. So B becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions. So we first found the first derivative and second derivative of this function f of x. Then we just put x equals to 1. So we got three equations in terms of a, b, and c. And when we solved them simultaneously, I got the answers for a, b, c as minus 1, 5, and minus 5 respectively. Then we just find the sum of the squares, and that matches with option B. So B becomes the correct answer. I hope you have understood this. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do comment on my channel and share this channel with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions that we are solving. Thank you.